Let's go through and have a quick recap on horizontal launch. We read an example that a person is shooting using his gun towards the bird, but the range of the gun is very small, so the bullet will fall after some times here. So that is in this way it will fall like this. So here it is going parallel, till here it is going parallel to the ground, then afterward it is forming a curve. So this is horizontal launch. Whenever parallel, it is that whatever objects or things are thrown uh, or shooted, so it will fall down onto the ground. After running to some few parallel direction, then it will fall down. So this type of launch is called as horizontal launch. We will take another example for horizontal launch. Like suppose a table is there, and a boy is rolling a car, push car, small toy car. So he will roll the car on the table. So after some time this car will come here. It will run parallel to the ground level, and then afterwards it will fall down like this. So this is horizontal launch. Here also it is parallel to the ground level. So in this way this type of launch is called as horizontal launch. Now further we will study vertical launch. What is vertical launch? In vertical launch it could be of both sides. Suppose a person is standing on a cliff and throwing a ball to some angle. So some angle is formed like this, or some angle here theta. So this is the angle. He is throwing this. So after sometimes it will fall. It will go up and then it will fall. So this type of launch is called as vertical launch. And instead of throwing it upward, if the person throws it downward, then also it is vertical launch. I will explain you. So here the person is, this is parallel, so he is not throwing in this direction. Instead he is throwing downwards ball. He is throwing the ball downwards. Then this is also a vertical launch because angle is formed downward. So this type of in two conditions this vertical launch can happen. He is throwing upward, something is thrown upward, or something is thrown downward. So this type of things is called as vertical launch. From some height something is thrown downward, then it is vertical launch. And if something is thrown upward to some angle, then also it is called as vertical launch. Angle is formed. So this is the important criteria. Angle formed which is greater than 0, but here angle is not formed in case of horizontal launch. It is parallel. 0 angle is formed. So here I will give the example. The boy is throwing the ball. So boy is standing onto the cliff and he is throwing a ball like this, but he is throwing not upward. He is throwing the ball parallel to the so ball is moving parallel and it will fall down later on. So this line is parallel to this. So when it is parallel, this is forming like parallel lines. So this type of launch is horizontal launch. So for horizontal launch, we have understood that we have taken few equations and we have done questions. So these are the basic rules for horizontal launch. Like for a straight line launch which is parallel to x-axis, angle formed is 0. So that we have discussed. Normal straight line kinematical equations are used to find out displacement, velocity and time. Like s equals to ut plus half at square, v square equal to u square plus 2s, or v is equal to u plus at. These three equations are only used here. considering the value of g as positive or negative. This we have to consider very nicely, and we have to remember the important point that if object is thrown away from the earth, then it is moving away from the earth, then we have to take g as negative. And if object is falling towards the earth, then, or if object is falling or thrown towards the earth, and it is falling down, uh, initially it has been thrown towards the earth, then g is taken as positive because object is thrown towards the earth. Now we have to consider what happens to the vertical launch. If suppose some angle formed which is greater than 0, then what will happen to the acceleration and velocity? Here it is very important, we should understand that. So here velocity, horizontal direction velocity is constant. So what it means, like see, if something is thrown like this, a ball is thrown upward, so the ball will move like this and will come down here. So here you can see the velocity along the x direction, means along the line which is parallel to the ground. So this is ground, so these lines, this line parallel to the ground, this line, so velocity in this direction, this 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 will always be constant. Suppose the person is throwing the ball at 5 meters per second, so here also it will be, at this point also it will be 5 meters per second, at this point also it will be 5 meters per second, at this point also it will be 5 meters per second, which is parallel to the ground level. So all this, it will be 5 meters per second. So horizontal velocity remains constant. Okay. Now here vertical directions velocity y-axis changes with the g. So we will take this same example. The person is throwing the ball, so ball will move like this. So here we can see the velocity is changing here. Suppose velocity here with the initial velocity of 5 meters per second, that is being thrown, 5 meters per second along the y-axis it is being thrown. So this is the y-axis. So here at this point the velocity will be suppose 5 meters per second, then later on it will become 4 meters per second, it will decrease 4 meters per second, then here it will become 3 meters per second, then here it will become 2 meters per second, and at the top it will become 0 meters per second in y direction, means upward, because upward it is not moving, it has become constant. Now it will fall down, 5 4 3 2 1, then again 0, then again here when it is falling down, then it will come, the arrow will come like this downwards, not upwards. So this you have to remember. So 0, then again it will become, from here then it will become 1 meters per second, 2 meters per second, then 3 meters per second, then 4 and 5 meters per second. Like that it will fall down. So it increases then decreases. First it goes on increasing, then comes to 0, then again start increasing. Okay, so this you remember, start increasing. First it goes on increasing, first it decreases, then it goes on decreasing, then from the top again it, when it becomes 0, then it again increases while coming downwards. So this is the rule which you have to remember for horizontal velocity. See, as we have discussed here, like this, so here it is launched like this, so you can see the velocity along this direction, which is parallel to the earth, is constant. So when the velocity is constant, like 5 meters per second it was, here also 5 meters per second at this point, here also it is 5 meters per second, here also it is 5 meters per second, here also it is 5 meters per second, and here also it is 5 meters per second. So everywhere it is 5 meters per second, which is parallel to the ground, means along the x-axis. So all the x component, x-axis, it is constant. So we can say here this it is velocity is constant. So if velocity is constant, means there is no acceleration, because zero acceleration will be there, because rate of change of velocity is acceleration. Acceleration is defined as rate of change of velocity. Here velocity is not changing in x direction, so that's why there is no rate of change of velocity. No rate of change of velocity or along x direction, along x axis or parallel to the ground. So there is no acceleration, means acceleration is zero. That's why acceleration along the x axis is 0, and acceleration along the vertical y axis depends on the g, gravitational force. Suppose a boy is throwing the ball, now he is throwing, so it is going against the gravity because he is throwing upward. So initial velocity is like this, so it will go upward, so it is minus g. We have to consider this as minus g. So acceleration along the y axis is minus g. But if a different case is there, suppose a boy is standing on a cliff and he is throwing the ball. So this is the cliff and he is throwing the ball here. So the ball will move like this upward direction, then it will fall. So it is moving again against the gravity here, so moving upward. So that will be a, because it is initially moving up, and here some angle is formed. So he has thrown this upward. So whenever he is throwing this upward, so some angle is formed. So he is throwing against the gravity. So here also a equals to minus g. But in third case, suppose a boy is standing on a cliff. Okay. Instead of throwing it upward, he is just dropping the ball. So he is dropping the ball, so ball will fall like this. So he is throwing this towards the gravity, and the ball is falling towards the gravity automatically because he is dropping the ball. He is not throwing upward or downward. So here actually he is just dropping it. So it is moving towards the gravitational force. When it is moving towards the gravitational force, then you have to consider a as plus g. So this is very important. So this you should remember well. Now we have to derive few equations for vertical launch. Before doing few sums, so we have to derive the equations. So first thing we will derive is time of flight. So for this, suppose a projectile is launched like this. So some angle is formed, that is theta here. So this is y component and this is x component. So here, but we will consider only y component for time of flight, because till here we will first find out half of this time of flight. So it will move like this. So it is moving like this. So here it will become parallel. So here this component. So this direction is u sine theta, which is perpendicular we take as sine theta, and this direction which is parallel we take as u cos theta. So here also u sine theta, upward is u sine theta, and parallel to the ground is u cos theta. So in this way, we will first find till here for y direction to find the time of flight, because time of flight means it is moving upward and then downward. So time is for this only, from upward to the downward. So if we find from here to here, this t from here till here, then we will multiply with 2 and we will get the remaining also. So time of flight, for that we will derivation we will use few things. So we have to find from this direction to this direction, A to C, and here B is there. So for this, first we will find only A to B, then multiply by 2, because from here to here what is the distance traveled is all equal to this only. So this A to B is equals to B to C. So first we will find for A to B to derive this equation. So initial velocity along the y direction is u sin theta, and acceleration along the y axis depends on g, and the ball is thrown upward against the gravity, so we will take it as minus g. And velocity along the y direction is considered as, so velocity along the y direction, that is final velocity, because when it will reach the ground the velocity will become 0, so we will take it as 0. If we want to find time, so we have three kinematical equation: v square equals to u square plus 2s, s equals to ut plus half gt square. So here time in s equals to ut plus half gt square, time is there, and v equals to u plus at also time is there. So we can use this equation v equals to u plus at to derive this. V equals to u plus at. So here you can see we will now substitute the values here. So velocity, final velocity equals to velocity, initial velocity plus acceleration into time. So all this now we will substitute the value. Vy, here it is 0 given, so we will write here 0. Uy, here it is given u sin theta, and acceleration is given by minus g, so plus minus g, and then into t. So now till here we have done. Now we will rearrange this, all this we will rearrange. So t, we can take this side. If we write like this, t equals to u sin theta upon g, because it is g na, so g will come down. So here g will come down, and it is coming in other direction, so it will become plus g. This when we are substituting the value, it will become. So as you can see here, so we can write like this also. So gt minus gt equals to minus u sin theta. Minus gt equals to minus u sin theta. So minus g equals to minus u sin theta. Okay, so we can write like this, t, or we can write this as, now this negative will go away, this negative will go away. Now here this we can take, here t we can take in this direction, and g we can bring it down. So t equals to u sin theta upon g. So this is the same thing what we have got here. So this is the time of flight till A to B. This is the time of flight till A to B, from A to B, from A to B. Now A to B is this one. Now from B to C is also equals to A to B only. So if we want to find A to C, flight of this time of flight from A to C, then we will just multiply this whole thing with 2. So here we can write like this, t equals to 2u sin theta upon g. So this we can write as capital T, because from A to C we are taking. Capital T equals to 2u sin theta upon g. Now second derivation we will do is for the maximum height or y max. So here you can see in the same projectile. So you can see in the same projectile here, we have to find this maximum height or y max, means along the y direction how much maximum height it has attained along the y direction. So this is y direction and this is the x direction. So this is how much, this is the maximum height which the ball has reached. So this we will write as y max or h. We will consider this as h. When we are deriving this, so we need s, we want to find this s value which is equals to capital S. So we will find out maximum displacement. So we will use this formula, v square equals to u square plus 2as to derive this. So here we can take this from A to B direction, from A to B direction. At B it is at the maximum height, and at C it is again coming to the ground level. So this is the height which we want to find out, this B, point B. So we will write along the y direction, initial velocity along the y direction is u sin theta, and final velocity along the y direction is 0, because here it is becoming 0 now, vy equals to 0, vy equals to 0. Final velocity along the y direction is 0, and acceleration along the y direction is equals to minus g, because it is thrown against the gravity, so it is minus g. Now we will use this formula and substitute the value. V square equals to u square plus 2as, v square equals to u square plus 2as. So here v square means 0, this is the value, v square means this one, v along the y direction. So we can write 0 equals to u square means u sin theta plus 2g and s equals to h, this displacement. So yes, we can write like this as h, 2gh. So here h, so now we will bring this side, this one, so minus 2gh equals to u sin theta. So this is minus g, so here we can write here minus g. So this minus g, when it will come here this side, so it will become plus here. So this side it will become plus, minus g will become plus here, and u sin theta. So here in this way it is there. Now h equals to u sin theta upon 2g. So u square sin theta upon 2g. So here we have taken this as u square, so we will square this also and this also. So this also we will square it. So it will become h equals to u square sin square theta upon 2g. So this is y max. We can write maximum height along the y direction, y max. Also it is called as y max. So y max or h is equals to u square sin theta upon 2g. Now we want to find maximum range of the projectile. Means we have now found h direction, maximum displacement along the y direction. Now maximum displacement along the x direction we want to find out for this projectile. So here it was A, B and C, means total distance. This is the distance from A to C, means this distance we want to find out from A to C. This is the distance we want to find out, how much it is there. So this is called as range also. So we will find out. We found for y direction here, that was H, capital H. Now we will find out range along the y direction. As we know very well, along the x direction it is considered as u cos theta, and along the y direction it is considered, initial velocity is considered as u sin theta. So we will write all the values for x direction. Now we are finding out. So for x direction we know u x, initial velocity along the x direction is u cos theta, and acceleration along the x direction is 0 because there is no change in the velocity, and displacement along the x direction is, we have written it as range r. So time we will consider it as capital T. So now we will substitute the values of everything. So here S equals to ut plus half at square, Okay, so here we will now substitute the values here for this. S is equals to r, so we will write r equals to initial velocity u is equals to u cos theta, so we will write u cos theta. Okay, so into time, we just derived previously, time is u sin theta by g, 2u sin theta by g. Then acceleration along the x-axis is 0, so plus half into 0 to 0, so this whole thing will become 0. Okay. So now r equals to u cos theta 2u sin theta upon g. We can write this as uu, this u we will write here. These two u's we will write as u square, r equals to u square cos theta sin theta by g, 2 cos theta or 2 sin theta cos theta upon g. So this is the formula. So 2 sin theta cos theta is also given as sin square theta. So we can write this range equals to u square sin 2 theta by g. So these two formulas are there. U square sin 2 theta, or range is given by this formula also. U square 2 sin theta cos